In this video, I'm going to talk about another method for solving systems of equations. That's very useful, especially when you start getting larger and larger systems, and it's called matrices. Section 3.3, the previous section, we dealt with larger systems of three equations with x, y, and z as the variables, and now we're going to do an alternative method here utilizing technology. It uses a calculator. So I'm going to run through an example and I'll show you the keystrokes on the calculator and the different features that it has. Hopefully you guys can work on the calculator and become familiar with this process. So I'm going to look at an example. It's actually one that we took a look at in section 3.3. First equation is 2x minus 4y plus 3z equals 17. Second equation is x plus 2y minus z equals 0. And the third equation is 4x minus y minus z equals 6. Now in the video from section 3.3, we solved this by hand using the addition method. In this one, we're going to use technology, and you'll see there's some benefits to doing it by hand. There are also some benefits to using the technology. So the first thing we need to do is to establish this idea of a matrix. And a matrix essentially is a rectangular, we call it a rectangular array of numbers. It's just numbers arranged in rows and columns. And so in this case, what we're going to do is we're going to pull off all of the coefficients and constants from the three equations and write them in rows and columns. Each row corresponds to an equation, and each column will be the coefficients of a given variable or the constants. Okay, so the corresponding matrix then is 2, negative 4, 3, 17, 1, 2, negative 1, 0, 4, negative 1, negative 1, 6. And so you can see how those numbers match up to the coefficients on the variables and the three constants on the right. In matrix, we typically will put a bracket on either side to close that in, to group it together. And then where the equal signs are, we usually will put a vertical line to kind of separate the left side of the equations from the right side of the equations. This is something we call an augmented matrix. It is a matrix that represents a system of equations. Okay, so this would be an augmented matrix. The matrix, any matrix has a size. It is named by the, or denoted by the rows and the columns. Okay, so typically your matrix will be row by column. In this case, we have 3 rows and 4 columns, so we would call this a 3 by 4 matrix. Okay, so now, again, the number of rows by the number of columns. Okay, so what we're going to be able to do, or what we want to do, is we want to find an individual x value, an individual y value, and an individual z value. Okay, and so ultimately we want x equal to a number, I'll call it a, y equal to a number, I'll call it b, and z equal to a number, I'll call it c, and then we put those together in an ordered triple as our final answer. And so we don't know yet what a, b, and c are. Now you guys might remember from the previous video what the answer ends up being, but I'm not going to share that just yet. But if you look at these three equations, x equal a, y equal b, and z equal c, they are equivalent to they're equivalent to a system with 3 variables where a bunch of the coefficients are 0 and 1. If you'll notice, if you think about it this way, x equals a is the same as 1x plus 0y plus 0z equals a. right? So if I expanded this, if I think about, zero coefficients and reduce this down, the 0y and the 0z are gone, you just get x. Y equals b is the same as 0x plus 1y plus 0z equal to b, and z equals c. If I expand that out, is 0x plus 0y plus 1z equals c. And so this system could be represented also by a matrix. And it's what I would call the solution matrix, or what your calculator will call the RREF matrix. And I'll explain what that means in just a moment. And so this matrix is 1, 0, 0A, 0, 1, 0B, and 0, 0, 1C. Okay. If you can somehow transform the original matrix into this matrix, then the solution to the system will be the three numbers on the right. They represent the x, the y, and the z values. Okay. Okay. And so this matrix is called the reduced row echelon form. You don't necessarily need to know that phrase. Reduced row echelon form is abbreviated as RREF. That's what your calculator will call it, and that's what I will call it from here on out. This is just the long way. So basically, you're reducing the original matrix down to this form. The row echelon, basically, echelon is just a formation. So it's a specific formation where you have ones on the diagonal and zeros in other places. So the reduced row echelon form is just this sort of format. You can turn any matrix into this reduced row echelon form. There are certain tricks to doing that, or techniques to doing that, called row operations that we're not going to cover in this class. But they can be done, and there are algorithms built into your calculator that essentially do those things for you. And that's what we're really going to focus on, is what the calculator can do, okay? Or how you can do it on the calculator. All right, so what we're going to do is we're going to enter this matrix, the original matrix, into the calculator and have it find the RREF form, which will just basically pop out the answer on the right. So we're going to go to, we're going to turn our calculator on. Oops, I've got some stuff stored in there from a previous class. Let me get rid of that real quick. Okay. Now what I want to do is go to the matrix menu. The matrix menu for many of your calculators will be the second feature, and there's a glare on there. I can't hide the glare. Maybe the second feature of this X inverse button. So if you hit second and then the X inverse, you'll get the matrix menu. Now some of you, if you have a different calculator, it may be somewhere else, but all your calculators should have some sort of matrix menu on it. While I'm going through this, I'm going to move the calculator over. Oh, that hides pretty well. And I'm going to go through and list out the steps for you as we go here. So you're going to do the second button and then the X inverse button, which takes you to the matrix menu. Okay, that's the first thing you do. Then along the top, you have three different menus within the matrix menu. You have the names, math, and edit. You want to go over to edit. And then I've got some matrices already entered in here. Don't worry about that. I'm just going to take the first matrix. You guys can go ahead and do that. Just hit enter on matrix A. You can actually enter several matrices. This first one is matrix A. It's the first one, and it's the one that I'm going to use for this problem. So I'm going to select 1, which is matrix A. Oh, it doesn't have the, Let me see, when I go back in there just to test that out. Oh, it doesn't have the word matrix, it's just the A. Either way, close enough. All right, so I want that. Then you give it a size. You can type whatever size you want. Mine already has 3x4, and it is a 3x4 matrix we're doing, so we'll go 3x4. Oh, what am I doing? 3 enter, 4 enter. There it is. Okay. And then it's going to give you a bunch of values here. If you're doing this the first time, it should be all zeros. What you want to do then is type in row by row the entries from the matrix. So let me put this, you're going to enter your size, enter the size, and again the size is row by column. All right, and then you're going to enter the values. Okay, and so I'm going to switch back over to the other side here, and I'm going to enter all these values again. You go row by row. So it'd be 2, then enter, then -4, enter, 3, enter, 17, enter. Then it'll go to the next row. 1, enter, 2, enter, -1, enter, 0, enter, 4, -1, -1, and 6. And so I've got everything entered in there. Then I'm going to go second mode, which quits and goes back to the home screen. Okay, once you've got everything entered, you want to go back to the home screen. So you hit second and then mode, which allows you to quit. Q-U-I-T, there we go. Okay. So we have the matrix now entered in the calculator, and now we want to convert it to the RREF form. To do that, we go back to the matrix menu. So you hit second and then matrix again. So second, the X inverse button to go to matrix. We want to do some math on the matrix, so we go over to the math menu. And the math we're going to do is the RREF, which is not shown here. You have to scroll down quite a ways. And there it is. It's the option B. Okay, you'll see B colon RREF parenthesis. That's the one you want. So I go to that one, I hit enter. It's going to show up RREF in my home screen. Then I want to tell it what matrix to reduce. So I have to go again back to the matrix menu, second. And then the X inverse takes you to the matrix menu. And then under this names menu, you select the matrix you want to reduce, which in our case is matrix A. So I hit enter there. It puts the A in the parenthesis. I then want to close the parenthesis. Actually, if you don't close the parenthesis, it should work okay, but I'm going to close it anyway. And then you hit enter. And you'll see the reduced form of the matrix pop out. Okay, that gives you all the keystrokes then and different menus that you need to be able to perform this operation. So looking at the other side here, you'll see the reduced matrix with the ones in the diagonal, the zeros elsewhere, and then the numbers on the right-hand side. The numbers on the right will represent the solution to the system. And so in this particular system then, because our reduced row echelon form is 1 0 0 3 0 1 0 1 0 0 1 5, that tells me that the solution is the ordered triple 3 1 5. Okay, and therefore the solution set is the set containing that ordered triple. Again, we always want our solutions to be in set form. Now that answer should match up with the one that we found by hand in the previous section, and indeed it does. And so when you guys are finding these and doing the matrix form on a test, the work that I want you to show, and I am going to have you show work on these. If you do it by hand, you just do all the addition method work. If you do it with a calculator, you still have to show some work. The 3 things that you must write down to receive full credit will be this initial matrix must be written down. The reduced matrix must be written down. And your solution set must be written down. So there are 3 things. I consider that your work, quote unquote. There's not really a whole lot of work there. But you must have those 3 things written down to receive full credit if you solve using the matrix method. Okay, that should give you a pretty good overview. Again, the steps to finding the matrix are there on the left. Maybe I'll remove the calculator, and the example is there on the right.